So we'll take a look at a couple problems involving multiplying radical expressions and dividing radical expressions. What we're most concerned about here is understanding some of the basic radical rules when you do basic operations. So let's take our first example. Let's suppose we're multiplying the square root of 7 times 3 square root of 5 minus 2 square root of 7. Okay, now what I want to do here is I want to compare this a little bit more to a kind of a similar problem. Maybe if we did something like 5 parentheses 3x minus 2, something like that. Now usually when people look at this kind of problem right here, they understand that we're probably going to distribute. So we're going to distribute the 5 to the 3x and the 5 to the negative 2. So in other words, we'd be doing 5 times 3x minus 5 times 2. And then you do what you can in these cases. Like here you would do 15x, right, minus 10. And that would be your final answer. And so we're going to do something similar with the radical expression over here. We're going to distribute the radical 7 in here and in here. But the important rule to remember is that you can only multiply, well, you can multiply radicals times anything. However, you can only multiply numbers under the radical with each other. So for instance, this 3 and this 7 really don't have anything in common. But this 7 and this 5, they do. So I can really focus a little bit more on this right there. They're both under the radical. So how would this look when we multiply? Well, it would be radical 7 times 3 radical 5 minus radical 7, maybe I'll use parentheses here, times 2 radical 7. Okay, where can we go from there? Well, in this first expression, I know that that's going to be 3 times the square root of 35 minus 2 times the square root of 49. So notice how I multiplied the 7 and the 7 but kept it under the radical. Now as you get better at this, you'll understand another rule, and that is whenever I multiply a radical times itself, let's say 6 times 6, right? I actually get the number underneath the radical symbol. So that's actually what's going on here. So if in the future you can kind of pick up on this, radical 7 times radical 7, and really that's just 7. But for now we'll leave it as 2 radical 49. So we're going to bring this down, 3 radical 35. And then since we know what the square root of 49 is, we're actually going to write it. It's 7, right? And so that allows us to get a final answer as 3 radical 35 minus 14. Let's do one more. Okay, so in our second example here, let's deal with something more along the lines of 5 radical 2 plus 9 and 3 minus 4 radical 6. Okay, so now in a case like this, again, I'm going to draw a parallel to maybe a problem that you might have seen before. Maybe if we did x plus 5, x minus 3. We know this, a lot of times we know this as the product of two binomials, but we know it a little bit more commonly as FOIL. Okay, it stands for first, outer, inner, last. But I think what I've seen lately is people are a little bit better off with the distributing rule and staying with the distributing rule. So we're going to start with the 5 radical 2, and we're going to distribute him there to the 3 and to the 4 radical 6. And then what we'll do is we'll come back and grab this 9 and distribute him also to the 3 and the 4 radical 6. So let's start with our first set. 5 radical 2 times 3 minus 5 radical 2 times 4 radical 6. That takes care of the distributing with that first term. Now, meanwhile, we're going to have to add to that, right, what happens when we distribute 9 times 3 and then minus 9 times 4 radical 6. So let's continue on here, right? Let's actually multiply. Remember, we can only multiply coefficients times coefficients, and we can only multiply radicals times radicals. So we have to keep those kinds of things in mind. So this first expression, 5 radical 2 times 3, that's going to be 15 radical 2. Now we have to take a look at this guy right here. 5 times 4, 20 radical 12. Okay, now we go to 9 times 3, 27, minus 9 times 4 radical 6, which is 36 radical 6. At this point, we take a quick look at what we have, and we look to see if we can do one of two things. Number one, can we simplify? And then number two, can we combine like terms? So it looks like the only thing maybe we can simplify is right here, and that would be just me taking that radical 12 and splitting it into radical 4 times radical 3. I know the square root of 4 is 2, so I'm going to multiply that times 20, and this particular term is going to be 40 radical 3. But I take a quick glance around, and I don't really see anything else here that I could combine. So my final answer is a little long and a little tedious, but it is correct. There we go. Okay, let's take a look at dividing radicals, which again can be a little bit tricky sometimes. So let's suppose we had 8 plus radical 5 over radical 2. Now our major concern here is the radical in the denominator. It's not standard to keep a radical in the denominator, so what we're going to have to do here is we're going to have to what we call rationalize it. Okay, the process of rationalizing is multiplying this fraction, numerator and denominator, by the expression that is going to eliminate the radical in the bottom. So we saw before a rule like this. If I multiply a radical times itself, that would actually equal radical 9, but that's the same thing as 3, right? So in essence, the radical goes away. So that kind of gives us a clue here. What we want to multiply here by is radical 2 over radical 2, mainly because it will eliminate the radical on the bottom. So what does that look like? Well, on top, we're going to have to go back to our old friend distribution. And on the bottom, we'll just straight multiply across. So we'll have 8 radical 2 plus radical 10. And all of that will be over 2. And that's it. Let's look at one more example, maybe a little bit more difficult. What happens if we have 5 radical 3 over 6 minus radical, let's say, 7? Okay, now we have a little bit of a problem. So allow me to kind of do something incorrect for a little bit. If I were to multiply 6 minus radical 7 by radical 7, based on what we just talked about, then it would make you think that the radical will go away, and that is only partially true. Right here it will equal 7, but not here, right? When I distribute, I'd actually have 6 radical 7, so you would actually wind up making that denominator worse than you started. So we don't want to do that, right? So what we're going to do here is we're going to multiply by what we call the conjugate. Okay, a conjugate expression is simply the opposite sign of our initial expression. So in this case, the conjugate here would be 6 plus radical 7. If the problem started with 6 plus radical 7, the conjugate would be 6 minus radical 7. So let's take a look. Let's start over here. We go 5 radical 3 over 6 minus radical 7. What are we going to do? We're going to multiply that times 6 plus radical 7 on the top, 6 plus radical 7 on the bottom. So you can tell on the top we're going to have a little bit of distributing. We've seen that before. And on the bottom we're going to have a lot of distributing. It goes back to that FOIL. So on top we get 30 radical 3 plus 5 radical 21. Notice there's that rule again, multiplying a radical times another radical, keeping the number inside the radical. And on the bottom we're going to do 6 times 6, that's 36, Then we're going to do 6 times radical 7. That's just 6 radical 7. Then we're going to do negative radical 7 times 6. And then finally, negative radical 7 times radical 7. And if we do this correctly, what should happen is those middle terms should cancel out, leaving us with a final answer up top of 30 radical 3 plus 5 radical 21, all over 36 minus 7, which is 29. And that'll do it.